Okay. I'm going to start off by asking our usual icebreaker questions. So, Adarsh, what happened to Zoom? Okay, so here's what happened to Zoom. Today, I did a little test meeting where I joined it and just like sat there, and it kicked me out. So basically, Zoom, it used to be that you could like make a meeting for with your JCPS account and you would like have unlimited time, right? But now we can't. So now it has a 40-minute time limit, and this class is not 40 minutes long. It's actually 90 minutes long. So yeah, we can't use Zoom. So we had to scramble for a solution, and this is what we came up with. I mean, we could just we could restart the meeting, but the issue is that then the recording gets chopped in half, and also some of you guys might just bail out and leave. So yeah, Google Meet also has a time limit. It's a 45-minute time limit. But as you know, our Kahoots usually go over by a couple minutes. $60 minutes? Oh, sorry. Yeah, it is 60 minutes. But still, the issue with Meets is that I can't record on Meet at all. So yeah. Really? You can record? Yes, but that only works if you have a teacher Google account. And even though I am a teacher to you guys, I don't have a teacher Google account, so I can't record. Also, is it just me, or is everything in the chat being like repeated twice?
I think it's just you. Because
Okay.
it's not happening with me.
Oh, okay. That's weird. Like everything in the chat is like doubled, so like every time you type in something, it shows up twice. That's
yeah. Weird. No, we don't see that.
Okay, that's just on my side then. All right. We'll just start with a couple of questions. So first question, would you rather have your flight delayed by 8 hours, or would you rather lose your luggage? And Kyung has to do something. I forgot what it was because I forgot. So, yeah, so she's not here today. I'm going to have to teach it by myself, so I'm going to be kind of lonely. Delayed, you can explore the airport that way. For 8 hours, like say your flight had to come at like 10, or well, actually it wouldn't be too bad. It would only be bad if your like flight was supposed to come in the evening.
No, that's not. I mean, that is kind of bad, but you could just like go to some restaurant or something.
And
or if you're first class, there's those lounges. Like if you're first class.
That's true.
So that'd be nice.
Yeah. My only concern is that like if you're in like some random place, like say you're like traveling to, I don't know, New York, right? And you get stranded and your flight has like an 8-hour delay and you're like stranded in like Washington, D.C. for 8 hours. Actually, that isn't even that bad. I mean, it kind of depends. Yeah. I mean, for me, I would rather get delayed for 8 hours because if you lose your luggage, it's just like you lose. There's no guarantee you're going to get it back. If it's a business trip, it'd be pretty bad. Yeah, that's the thing. It's like if you lose your like suitcase, you lose your phone, unless if you have it on you, but like you have like some like important stuff in there because you're obviously traveling, so you're gonna like lose everything. Oh, what happened? Who is Ian?
Are we allowed to screen share?
Let's just say that we came up with the solution like 30 minutes before class, so you're probably going to be able to do a lot of stuff. Okay, I'm gonna ask another question. If you could pick one skill to be an expert at, oh my gosh.
I was gonna do that.
I'm going to like figure out how to not let you guys screen share.
No.
So you've lost your screen share privileges. Let's see. How do I do that?
Just
Okay,
say that they're gonna lose points if they screen share.
Yeah. That's a good idea. If you screen share, you lose like 5 points.
I need points anyway.
If you rickroll us again, you lose all your points. I still can't figure out how to not let you guys screen share, so I'm just gonna do that instead. So anyway, the question was, if you could pick one skill to be an expert at, what skill would it be?
The skill to learn any skill within 2 seconds.
That's pretty clever. Yeah. That's pretty smart. Yeah, I would do that too. This skill to learn any skill. Okay, one last question before we get started. You can have an unlimited supply of one thing for the rest of your life, and it has to be an object. It can't be something abstract or anything. If you can have an unlimited supply of one object for the rest of your life, what would it be?
Does it have to currently exist?
Yes.
Dang it.
It has to be an object. Electricity is not an object. It has to be a specific object.
I would say money.
like what? Like money is not an object.
$100 bills.
That is an object. Credit cards.
You want a bunch of credit cards because then you can go into serious credit card debt.
Okay, if it's not money, then what would it be? Like, it can't be money. It can't be anything that has been considered like money. Although, like I mean, technically you could say anything is money, but
$10,000 PCs because I could just sell them.
Could we say a private chef?
yeah.
Why would you need
You
more
could-
than one private chef?
Just one. I don't know.
You could just.
I
mean,
okay, how about golden necklaces? Because then I could sell them for money. Aha, big brain.
okay. I guess you could do that because, like, I mean, on that note, you could just sell anything.
Can I say humans? Because then I could technically have an army with infinite numbers.
That sounds a little weird. maybe don't do humans.
Yes. Let's take over the countries.
I mean, who's gonna stop an army of unlimited humans? Loyal humans. Sorry.
That's a good question.
No, I said loyal humans now. Doesn't it at that point just become slavery?
It's a fine line. I think there's a dark mode on. There should be a dark mode. I don't know if there's one on the app or on the web, but I know like for the app there is a dark mode.
Oh, there's a dark game.
Oh, you're on the app?
No, I'm on the
Isn't
web.
the
I'm on the web. It's
I don't think the web has a dark mode.
no. If you click more, Then it'll say
Oh wait,
dark
you're
mode.
right. There is a dark mode. Okay. We're all discovering this together. There's like 3 dots and then there's like a dark mode thing. Oh, you downloaded it? I think there should
Much better.
yes.
We're
dark
just
mode.
asking, why are we using this? I'd rather be like,
Oh, it's because Zoom, previously we were making our Zoom meetings with our JCPS account because with JCPS you don't have a time limit, but Zoom just lifted our unlimited time. So now instead we have a 40-minute time limit for Zoom. And our classes are 90 minutes long. So yeah. And we don't want to like split our recording in 2 pieces. And half of you guys are just gonna leave if we like have you guys rejoin the meeting. So we just did this instead. So yeah, we're still trying to find a solution though. All right, let's get started. Okay, I can't really see the chat, so if you need something, you should probably just shout it out. Okay. All right, so today is our second day with circles, and but we're not going to be like doing area and perimeter today because we're past that. So today we're going to be doing like angles and circles. But before that, we're going to be doing a homework review. Oops. All right, I'll share the link with you guys. Wait, did it send? Here. Okay. So this first question, number 10, actually last week's homework was pretty easy, but as a warning, I think this week's is going to be a little bit harder. So, okay, number 10. If the area of the circle is 25 pi inches squared, then what is the diameter? So, the formula for the area of a circle is pi r squared.
I can't see the slide.
Oh, did
I can see the
not?
presentation, but I can't see slide.
Oh, okay. Let me stop sharing and share the right one. Oh, I'm not even recording. Shoot. Oh, never mind. I am. Okay, whatever. Okay, pi r squared is the formula for an area of a circle. So this should equal 25 pi inches squared. So if you divide both sides by pi, then you get r squared equals 25. So r, which is the radius, is 5. We're not done yet though because the question is asking for the diameter. So the diameter is twice the length of the radius. So the diameter would be 10 inches. Okay. The next question is, I can't see the number. Number 8. So it says find the area of the shaded sector of circle O. And the radius is 6 inches and the central angle is 100 degrees. Express your answer to the nearest tenth of a square inch. So first, just as a reminder, to calculate the area of a sector, we just set up a ratio. So it would be this degree of the sector divided by the degree of a full circle, which is 360 degrees, and that equals the area of the sector divided by the area of the full circle, which I'm going to represent by this symbol. So the area of the full circle is radius squared times pi, so that would be 36 pi. And we know that the degree of this sector is 100 degrees because it says so in the diagram. So now what I would do is I would just multiply both sides by 36 pi. So that was the 36 pi goes away from this denominator and is multiplied on this side. So now if we simplify, that simplifies to 10, the area as to 10 pi. And that is 31.4 inches squared, so the answer would be C. Oh, Is that it? We did not do number 9. Oops, sorry. So number 9, what's the formula for the circumference of a circle of a given diameter? So for this one, the circumference formula is just 2 pi r, but since diameter is twice the radius, in other words 2 times pi, then these two terms can just be replaced with d. So the circumference would be pi times d. So the answer would be C. Okay, are there any questions? Okay. Yeah, the screen, my screen looks like I'm on an iPad because I'm doing a split screen, so I can try to keep an eye out on the chat, even though it's clearly not working. Uh-oh. Okay. All right, so today, as I already said, we're going to be learning about angles and circles, and today is going to be harder than usual. It's probably harder than usual because I made the lesson today, so yeah. So a couple of things to note before we get started. So if you're ever stuck on a question, just remember that essentially it's just a puzzle and you just need to think outside the box. So don't be afraid to try something new. And if you're really stuck, you can just ask for help. Like there's no big deal. Just ask for help. Or if you can also ask for a hint if you want to try to keep figuring it out by yourself. So on that note, we're going to be spending most of class on Desmos today. Just go to student.desmos.com and this is the code. I don't know if we're going to continue to use WebEx. For now, this is just a temporary fix so we can have class today. But I don't know for sure. We're going to try to get a premium Zoom or some other better platform account. So, all right. Oh, shoot. Okay, I'm going to put
the code.
The code is GB6PHX. And I'm just going to put that in the chat like 15 times so you guys don't miss it.
Just saying, why couldn't you? Oh, is it because you not do Google Meet because there's no annotation?
Well, no, it's just for Google Meet. It's because we can't record.
You can't?
No,
Oh,
teachers
yeah.
can, but like we don't have a teacher like Google account, so we can't record. Desmos is this math tool.
Wait, just asking, what account do we sign in with? Our personal Gmail or our school Gmail?
It doesn't really matter, just as long as we know your real name. Okay.
Could we answer the first question on there?
Sure, go on. You can just go on ahead. Yeah. And oh yeah, just to reiterate, here, I'll stop sharing and share to the correct screen. Yeah, so for Desmos, I don't really care how long your answer is, just as long as it's like I can understand what you're saying. So if you just write one word, if it gets the point across, that's fine. And so like that's how long your answers need to be. And you can definitely ask questions. Okay. Okay, so I'm just gonna try to see how many people there are. There's 24 people. Okay, so slide 2, drag the red point. What do you notice about the angle? So most of you guys said that you noticed that it was always 90 degrees no matter where you dragged it. And that's because there's this cool property. Basically, if you draw a triangle inside a circle, right, sort of like this, but the hypotenuse of the triangle is a diameter, then that triangle will always be a right triangle. So it will always have a 90-degree angle. And that's just overall pretty helpful because in all honesty, right triangles are much easier to work with than other types of triangles. So just keep an eye out for whenever you see a triangle that has the hypotenuse as the diameter of a circle. Okay, next question. Drag the red and blue points. What do you notice about the angles?
I don't know what I did, but I managed to glitch it out so that so I can get the angle of 158.
158?
Yeah.
Yeah, if you drag it on the other side, it becomes 158. That's not really what I meant to do. So, yeah, don't worry. We'll get to those angles in a moment.
Okay.
Yeah. So for this slide, I sort of intended you to find that these angles are always the same. And if you notice that these angles actually have the same endpoints. So like the red angle shares these two purple endpoints, and the blue angle also shares these two purple endpoints. And the thing is, as long as they share these two purple endpoints, they're always going to have the same degree measure, no matter where they are on the circle, unless you're like on it and you accidentally drag it like over here somewhere. Like if you drag it. Oh,
It's not possible unless you drag the circle around.
Oh, yeah. Yeah, if you mess with some things, you can find some weird. But like for our purposes, as long as an angle has the same endpoints on the circle and its vertex is on the circle, then they're always going to have the same degree measure. Also, the type of these angles is also special because these angles have all of their vertices on the circle. So this type of angle where it's like all on the circle is called an inscribed angle. Okay, this one now. Drag the red point and then adjust the position of the orange point. And the blue angle is at the circle's center. So what relationship or pattern do you see between the angles? Like the red angle and the blue angle. and specifically pay close attention to the measure of the angle. So like currently the blue angle is 72 degrees and the red angle is 36 degrees. If I drag it some more, here the blue angle is 110 degrees and the red angle is 55 degrees. If I drag it some more, the blue angle is 174 degrees and the red angle is 87 degrees. So you may notice something about it.
What do you mean outside the blue angle?
I don't even know. You shouldn't be able to mess it up, but it's just saying that the red angle should be like, it shouldn't be, I mean, I don't know. I don't know what it means. Just ignore that. Yeah, I don't know. I made this though, so I mean, I should know, but no. All right, so basically the answer is that the blue angle is actually like twice the measure of the red angle. It doesn't, like, there are some times when it isn't quite like twice the measure. Like, for example, right now, this says 59 degrees, but over here it says 29 degrees. Like, it's close, but it's not fully accurate. And that's just because Desmos doesn't show decimal places, so sometimes it's a bit off. But in real life, if you draw like two angles with the same endpoints on the circle, A and B, and you have one angle is connected to like the center of the circle, and the other angle is connected to the edge of the circle, then this angle will be twice the degree measure of this angle. And this is like always true. And there are some names for these angles. Again, the red angle is called an inscribed angle, sort of like over here, these are inscribed angles. And the blue angle is called a central angle. And the central angle is like the central angle. And the red angle, the inscribed angle is always going to be half the degree measure of the central angle. And yeah, it doesn't, it's just because it rounds and it gets weird. Because that's why the degree measures aren't really here. This is better. How are they inscribed angles? Could you please explain inscribed angles? So inscribed angles are sort of like, here, let me just delete some stuff. Here, let's mess up this slide. Let me just delete this. Delete, delete, delete. Okay. Inscribed angles are angles where they have two endpoints on the circle. And they have like an endpoint, a vertex, and another endpoint on the circle. So this would be an inscribed angle. Kind of, you could just think of it as they have all of their endpoints and vertices on the circle. But a central angle would be this blue angle because it has two vertices on the circle, but the other vertex is at the center. So another example of inscribed are these, because both of these have all of their endpoints and vertices on the circle. Okay. So one more thing to note is that arc AB, the degree measure of, okay, question for everyone. What is the degree measure of arc AB in this picture?
63? Oh,
yeah.
Okay.
Yeah, you're right. It is 63 degrees. 63 degrees also happens to be the measure of the central blue angles, the central angle. So remember that you have to always remember that the central angle is always equal to the measure of its arc. So this blue angle, the degree measure is always equal to the measure of its arc AB. Okay. Any questions so far? All right, moving on. Slide 8. Drag the points. What do you notice about the relationship between these two angles again? Uh-oh. Whoa, this malfunctioned. Oh, and try to keep the shape a quadrilateral, specifically. That's how it's supposed to be. Okay, so first a few questions. What type of angle is the red angle?
Would it be an inscribed angle?
Yeah, that's what it is. And why is it an inscribed angle?
Because all its endpoints are somewhere on the circle.
Yeah, that's correct. All of its endpoints, this one, this one, this one, are on the circle. And why is it that when I drag this point, this angle doesn't change? If we go back to this slide, it's actually the same thing. Like when I drag this point, their angle doesn't change. And the reason is because they're always sharing the same arc. Like their arc doesn't change even when I drag it. So like these 2 points stay fixed. So when I drag it around, this angle also stays fixed. So on slide 8, it's actually a similar reason. These 2 points are not changing if I just drag one of them, like the endpoint here, or the vertex, sorry. The endpoints are not changing position. So when I just drag the vertex, the angle will stay the same. And it's a similar reason for this blue angle here. So why is it that when I drag the orange point, the angles both change?
Because it's an endpoint for both of the points, like for both the red and the blue angles.
Yeah. That's basically it. The orange point is an endpoint. So, and when you change the endpoint, the position of the endpoint, the degree measure of both of the angles will change because the degree measure of the arc is changing. So the arc is getting larger. So this blue will get, the arc over here will get larger. Arc over there will get smaller. So, what is that? And is a lot of you guys noticed that these two angles always add up to 180 degrees. And some of you guys also notice that this is a quadrilateral. So this leads us to our other property. Basically, when two angles are across from each other like this, so they share the same endpoints, but they're across from each other in the circle like this, then they will always be supplementary. So they will add up to 180 degrees. And this brings up an interesting point because that means whenever you see a quadrilateral inside of a triangle, their opposite angles will always add up to 180 degrees, which is kind of unique because normally quadrilaterals don't do that. So this type of quadrilateral is called a cyclic quadrilateral. So always just remember, if there's two angles, inscribed angles in a circle, that are across from each other, and they share the same endpoints, then they will be supplementary. Any questions about this? Okay, slide 10. Drag the orange point. What do you notice? Honestly, this kind of reminds me of a satellite, you know, just orbiting. Yeah, so lots of you guys have noticed that when you drag this around, it doesn't really do anything. The angle's always 90 degrees. And so what is this line in relation to a circle? So yes, exactly. This is a tangent line. And a tangent line is always 90 degrees to the diameter it's sort of like passing through. So just remember that if you have like a tangent line and you draw the diameter that like intersects it exactly at the point where it touches a circle, then that angle will always be 90 degrees. All right, so the next slide after this is slide 12. This one is kind of a throwback to one of our previous lessons. Let's see if you guys remember what they're called. Basically just drag the orange points. And yeah. Okay, so what you notice is that probably what you should have noticed is that the angles are always the same, like each pair is the same, and they're always across from each other. And a lot of you guys actually did remember what they're called, and they're called vertical angles. Vertical angles, they're always like across from each other, and they occur when you like have two lines intersecting, and basically vertical angles are always congruent. They're always the same measure. Yeah, there's really nothing more to say. Just look out for whenever you have intersecting lines because that will always have vertical angles. Okay, slide 14. Basically, this is just going to be a quick little review. using the previous slides, just write down as many pairs of congruent angles as possible in or not necessarily 2 minutes, just write down as many pairs of congruent angles as possible. So if there's an example given to you, angle BEA equals angle CED. So if you trace it out, BEA is this angle, and CED is CED. So this angle and this angle are congruent. And the reason they're congruent is because they're vertical angles. Basically, you just do that. Write down as many pairs of congruent angles as possible. And the other thing is that you're not just limited to the lines on the diagram. So like you can draw your own lines if you want to. So like if you want to connect line F to something, say, I don't know, line A, then you can do that. Just make sure they're connected to like one of the points that are already on the diagram. So you guys, I'm just gonna set like a, I don't know, 2-minute timer, and then I'll just check in once it's time. So far, it looks like most of the angles you guys are finding are all vertical angles. Try to find some angles that aren't vertical angles if you run out, because there are actually several. In fact, I'll give you guys one. This one, angle BAC over here is congruent to angle BDC over here. And the reason is because they're actually both inscribed angles and they have the same arc. So BAC is congruent to BDC. Okay, I'm just going to give you guys another minute. Okay, that's time. If you're still typing, just stop typing, and we're going to take a look at some of your guys' answers. Oops. Oh, here we go. All right. Rick Astley. Oh, wow, that's a lot of angles. Okay, let's find whichever one has the largest number of angles first, and let's just check from there. So this one has 5. This one has 5. This one has 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Aishwarya and Rick are tied. So let's
Aren't you gonna
just
check if they're legitimate or not?
yes, we will check if they're legitimate. So you guys tell me in the chat if their angles are real or not. Okay, so is angle CEO congruent to angle BEA and why?
Yes, because they're vertical.
Let me find it. CEO BEA. Yes. Okay, CEO and BEA are good. Is angle CED congruent to angle BEA?
Yeah, same. Wait, did they just? No, yeah, same thing.
Oh.
I think.
Oh, that doesn't count. You can't do that. You can't. That's the same angle. CEO and CED are the same angle. So CEO and CED, they're the same. You can't do that. Okay. Is angle BAC equal to BDC? Oh wait, let's go to Rick's. That's better. BAC BDC. Yes, why are they congruent? Why is angle BAC congruent to BDC? No one knows? Okay. Yeah. It's because they're inscribed angles and they share the same arc. So notice BAC over here has the arc BC. BDC also shares the same arc, so they're congruent. Okay. Oops. I think I might have cleared something. All right. Next angle, BEC. Wait, I need to remember how many angles. Okay, 2 angles so far. Is angle BEC equal to angle AEO? BEC AEO. They are congruent because of vertical angles. That's right. BEC and A, that doesn't count. The second one is angle BAE congruent to B. Oh my gosh. The last two are the same. Okay. In total, Rick has 3 angles because like half of them are repeats under different names. Let's check Aishwarya's. Where is it? Okay. Okay. Is angle BEA congruent to CED?
4 of them are wait, I'm not sure, but I think 6 of them are repeats, but I'm not 100% sure.
Yeah. Okay, the first one, this one is good. Their BEA is congruent to CED because they're vertical angles. Is AGD congruent to FOE? AGD.
Wait, they just made up new points. That was allowed? Didn't you say you could use, like, you could connect points, but you couldn't make up new points?
Yeah, yeah, that's true. You can't make up new points. You can make up new lines, but you have to keep the same points. That's okay. Okay, let's see how many of them don't use made up. Oh gosh. Okay, BAC. Okay, that one does count. BAC, BDC, AG. Uh-oh. Okay, Aishwarya, you have 2 legal angles. So it looks like the winner is Rick. Unless if there's someone else.
No, I have 5 though. Didn't he have 4?
Oh wait, no. Rick, sorry. Rick has only 3 legal ones, so we have to check some other people's. So
I have 5 too.
all right.
Yes, sir.
Okay, we have to check. Okay, let's go check the 5 people first. Aryan and Sanvi and Anand. Okay. Wait, where's the picture? Okay, whatever. Okay, Aryan, BEA equals CED. I think that's right. BOD equals EOD. BOD equals Okay, that one does not count. Okay, that one's like the same angle. I don't think straight lines should count. Do you guys think straight lines should count?
No. No, because they're not
Like-
really angles. They're just zero.
It is an angle, but technically the straight line is the same as itself.
If don't straight lines technically not exist because they don't have length
We
and
can.
thickness?
I mean, they still exist. Though. It is an angle, but it's the same angle as itself. Okay, let's
I
not
don't
count
think
that.
so.
Okay. Actually, you know what? Let's not spend so much time on this. Let's move on because I realize that we're going to be checking a lot of angles. We're going to move on and I'm going to check this like after class because I feel like we're going to sit here for like 15 minutes debating over if a straight line is an angle. I know. Sorry, guys.
Also never said that you couldn't repeat angles. And if
Okay,
you
but
back
that
on
is that's not. Also, you guys should not be adding angles.
Yes, you also
Oh,
said
okay.
not to. You never said to not repeat angles. So
Okay.
if we go off the count that you never said anything in the first place, I am
Okay,
the
but
one.
that's the same thing as like like if you repeat an angle, like the angle is like
I'm
so
not
like let me
disagreeing.
show
I'm
you
just
guys
saying
what an
some
angle.
people are saying
This
that
is an angle, and like this is an like this is an angle, right? So this like if you say AED, that would be the same thing as AEG because they're referring to the same angle. So that's why I wouldn't count those. Anyway, okay. Anne? What does Anne? All right. All right, we're going to move on now. All right, so now we're going to be doing practice problems. So basically, we're not going to do every problem, so you might want to pay attention because some of these problems are a little bit harder. So basically, the slides, they will have a duplicate image. One of them is like one you can draw on, and one of them is like one you can just mess around with. And if you need help, just ask me. Oh, and I just realized that Adarsh, I forgot to like address your question. So I'm gonna go back and address your question.
you can't mess around with this since they're all points.
What?
There's no movable points, so you can't really mess around with that.
Oh. If you scroll down, I think there should be one. Oh,
Yeah,
wait, never mind. I mean, but if you click the up arrow, you have controls. Okay, so Adarsh, I think you're confused about how to find the angle. So basically, there's a few different types of ways you can find congruent angles. So one way is to look for vertical angles. So vertical angles would just be angles that are across from each other. So this angle over here and this angle over here are across from each other. So they would be vertical angles and they would be congruent. So this would be angle BEA and this would be CED. So you can look for those types of angles. But the other type of angle you can look for are inscribed angles that share the same arc. So this angle here is BAC and it's on arc BC. So let me change the color to something. BC, arc BC. But this angle over here, which is BDC, it also shares the same arc and both of these points are on the edge of the circle. So these angles, BAC and BDC, would also be congruent to each other. And as another example, none of you guys pointed out this angle over here and this angle over here. ABD is congruent to ACD because they are, both of these endpoints are on the circle and they share the same arc over here. And also, none of you guys added lines here. If you added lines here, then you would have seen that angle CAD over here is congruent to angle CBD over here because they share the same arc and both of these endpoints are on the circle. So AOD equals AED. No, AOD would not equal AED because the problem with that is because AOD is over here, right? So they do share the same arc, but the points are not both on the circle. So like these points, this point is sort of just floating in the middle of the circle, and this point is the center of the circle. So they wouldn't be congruent because they're not on the edge of the circle. Okay, and someone asked if there's a Kahoot. There is a Kahoot. Okay, I think I left you guys on that question for too long. So, okay, let's see what you guys got for the answer. 5. Yes, that is correct. The answer is 5. And this is how you get the answer. So if you remember from our first slide, if you have a right triangle whose hypotenuse is the diameter, then this is a right angle. Yay! That means you can use Pythagorean theorem to find the length of the hypotenuse. So if you use Pythagorean theorem, then you find that this side length is 10, which happens to be the diameter. And since the radius is half of the diameter, then the radius would be 5. So 5. Oh shoot. So yay. Let's go to number 18. Don't do number 17. If you do number 17, we're not going to check it. So like we're not going to go over it. So it would be kind of pointless. So do number 18. Guys, we're not doing number 17. We're doing number 18. I love how just 5 of you have just gone ahead and answered, which isn't bad. It's just that we're not going to go over it. So if you, I mean, you can still answer it if you want. So
It was easy.
Yeah.
It was fun.
yeah, it wasn't too hard. So you can answer it if you want to. If you need help on this question, then you should go check out slide number 9. That might help. I love how you guys are just going back to slide number 9. That's not bad because honestly, you can reference it. Okay. Okay, I'll go over this question now. So slide number 9 over here. It says when angles are across from each other, they're always supplementary. And you could also say like in a cyclic quadrilateral, which is like a quadrilateral in a circle, then the angles will always add up to 180. So, whoops. Going back to slide 18, the angle X and the 158-degree angle are across from each other. So that means they're supplementary. So 158 plus angle X equals 180 degrees. So at this point, we just solve for x. So x would equal 22 degrees in order to make sure the angles are supplementary. And that's it. How? Like, why? Why? I don't remember why. So that's I don't remember why. Yeah, I can't really say much more. Yeah. Just remember it's a useful property though, because it helps you find like unknown angles, so you don't have to do anything crazy to find it. Okay, let's do number 19. Oh, wait a second. I'm sorry. Number 18 is not 22. Sorry. Okay. I didn't realize that this was not an inscribed. Okay. Okay, yeah, this question. Okay. Okay, here's the mistake I made, which I think you guys made a mistake too. Yeah, Jay, you're right. This is not, it looks like an obtuse angle. So this is a mistake we made. On slide number 9, in order for this to be supplementary, all of these had to be on the circle. So if it were instead like this, and this was 158, then yeah, it would be 22 degrees. But it's not, because 158 degrees is not on the edge of the circle. It's actually at the center. So instead, let's just say, like, let's see if anyone got it right. Oh my gosh, Sharvie, you changed your answer. I think it was probably right the first time, because yeah, so basically, here's the hint. What is the degree measure of this angle?
Is that angle measure 158? Because that doesn't work.
202.
Isn't that?
No, this angle measure over here, this big angle.
Oh, okay, 202, yeah.
Yes, this is 202 degrees. Or no, it's not. Yeah, it is. Okay, 202 degrees. And what do you guys know about inscribed angles and central angles? So notice that this whole thing, this degree, this angle labeled 202 degrees is a central angle that has this arc. And this angle x over here is an inscribed angle that also shares this arc. So what would be what's the relationship between the measure of an inscribed angle and a central angle?
Would this be like half of 202 then?
Yeah. Does that make sense? As a fun fact, I made up this question by myself. I made up everything in these slides. So I kind of fell for this trap where I thought this was like supplementary, but turns out it wasn't. So, I mean, yeah. I guess props to Jay for pointing that out. Yes, x would be 101 degrees because it's half the degree measure of this big angle here. And so, yeah. So it would be 1/2. And since this is an inscribed angle that shares this arc, it would be 1/2 the degree measure. Okay. Next question is number 19. Number 19? You actually don't need to do really a lot of math for number 19. It's like more of a like, do you see it question? Or have you read the question properly? So far, there doesn't seem to be any responses. What are you guys thinking?
Is B and A the centers of the circles?
Well, the question says it's circle A, circle B. So yeah, B and A would be the centers. The answer is not 90 degrees. That's a good guess by whoever guessed it, but it's not. Okay, you guys thinking of anything yet? No? Okay, I'm going to give you guys a hint. Try to connect AC, BC, and AB. Like, how do you, like, to find, in fact, I'll just tell you, to find the measure of arc BC is this part here, right? So you basically just need to find the degree measure of this angle here. So if you connect these...
And you know one of the points. Wait, wouldn't it just be the radius?
Yeah, Anna, congrats. You have found the...
Or half the radius. And yeah,
half the radius?
Radius.
It would be the radius.
Yeah.
Yeah, but no, here's the thing. What is AB? Like, what type of... Like, what is AB?
60? Is it 60?
Or no, I mean the line segment.
It's... Oh, what?
Like, what is... Not the length. Like, what type of... What is this? It's the radius, right?
Oh, yeah.
And what is this?
Also the radius. So it'll have to be
and this is the radius
60
too.
degrees.
Yeah,
then
exactly.
Be isosceles.
Or it would be equilateral,
Collateral.
actually.
Yeah, that's what I meant. I said isosceles.
Yeah, because here's the thing. Circle A and circle B are congruent, right? Which means they have the same radius, or radii, whatever. And since this is the radii, and this is the radius, and this is the radius, that means this is a 60, this is an equilateral triangle. And since it's an equilateral triangle, that means all the angles are 60 degrees, which means that to find the length of this arc, in other words, to find like the length of like, this angle here, that's just 60 degrees. Does that make sense?
So 60 is the answer.
Yeah. Okay, I'm gonna give you guys a hard question. Let's see, which of these questions should I do? Okay, I'm gonna give you guys this question. Oops, how do I get here? This is, okay, let me just extend it.
Maybe you can, maybe there's a way where you can only do 25.
Yeah, but then you guys wouldn't have access to the stuff at the beginning. This question is hard, but these types of questions, like this type of question comes up in math counts a lot, so I think it's a good idea to try it. This will be our last question before the Kahoot, I think.
Wait, so number 25?
Yes, number 25. So tip number 1 on this question says you need to draw lines on this diagram to solve the problem. So in other words, like use this tool and just do stuff. because you'll probably never get a geometry question in math counts where you don't need to draw something on the diagram. Like a lot of times you need to add stuff, draw like radii, draw tangents. And tip number 2 is don't forget that tangents and their radii intersect at right angles. So this angle here, this angle down here is 90 degrees. If you decide to connect here, this is also 90 degrees.
Wait, could you look at my answer and tell me if I'm right?
Okay. Yes.
Okay.
How did you get it?
It's because, do you want me to explain and say the answer, or?
You can just explain, but without saying the answer.
Okay.
That way other people.
So what I realized is, if the two circles are tangent to each other, then that means that if I just move circle B up, circle B up until B connects to A, then that's the same thing as line CD, and there really isn't that much of a difference. The distance between them would still be the same since they're tangent. So I realized that it's just the two radiuses, which is the distance.
I'm not sure how much that is right, but I don't think that's I'm not sure you're allowed to do that, but I guess you got the right answer.
Okay, here's a better explanation. So if I just drew a straight line from A to the right, if I formed a 90-degree angle like that, yeah, and then I formed a 90-degree angle to the other one, from B to, like, no, not like that. I don't know how to yeah, like that. Well, both of those are just the radius, and they meet exactly, since they're tangent to each other, then they meet at when the radius ends. I don't know how to describe it, but basically, if you draw a straight line, then that's A and B.
I don't think that's right. Actually, I don't think your answer is correct then. Because, yeah, I don't think your answer would be correct.
Yeah,
because here's the thing. If A has a radius of 12, right? So this would be 12. And then if circle B has a radius of 3, this would be 3. So this whole line here, this whole entire red line would be 15. So then how can CD be 15?
Oh, yeah.
So all of you people who put 15, I don't think that's the right answer.
Wait, I have an idea, but I don't know. I'm stuck.
Okay, you can present your idea.
Well, basically, I made a right triangle. So with CD, this is what we need to find, and then CA, and then AD. So that makes it a 30, 60, 90 triangle. And you know that.
Wait, how do you know it's a 30, 60, 90 right triangle?
Well, isn't it a right angle now?
Yes, it is a right angle, but is it a 30, 60, 90?
Yeah, because the insides of a triangle are 180, right?
Yeah, but it could also be a 31, 59. Or wait.
Wait, I have an idea of her idea. If that
angle, wait, right,
that's
true. That's true.
No, but I have an idea of her idea.
Yeah.
You could just draw a quadrilateral with all of its points. If you make a bigger circle, wait, would that work?
Not necessarily. You don't know if that goes into a circle or not. It might end up looking like this or something. Sure.
No, I'm saying like if you make a circle, I was thinking.
Now, all of you like who have presented your ideas, you're getting closer to the right solution. So like, wait, who had the idea of the triangle?
Sanvi.
Yeah, Sanvi. That's a good start. So in fact, the way you solve this is by making a triangle. I'm going to draw the triangle. Oh, do you see it?
I thought I saw it. Wait, is the top of circle B equal, like the same height as
No.
No,
No.
okay. I was gonna think then you can make a triangle.
Well, I'm going to show you the triangle you would draw. So this triangle here.
Oh.
Because if you notice, like this horizontal line here is the same length as CD. So really, we're just solving for the length of this horizontal line, this purple horizontal line here. So do we have enough information to solve for it?
Possibly, you know that.
Yeah.
You know C squared.
Yeah. We know the length of the hypotenuse because AE is 12 and EB, which is the radius of the other circle, is 3 here. Do we know what this is?
I'm not sure, but
I think
wait,
it's
would that
6.
be-
It's like half of AC.
Don't
We
assume
don't
that.
know that. It could be
Yeah.
6.1 and 5.9.
Do we know this entire length?
Yeah.
Yeah, what is it?
Oh.
Yes, it's 12. Do we know this length here?
No.
Yeah, since
Oh yeah.
the radius it's 3.
Yes, it's 3. So this is 3, right?
9.
So this is 9. Do we have enough information to solve?
Yep.
Yeah.
Solve and tell me what you guys get.
Wait, how'd you get the length for
Oh, it's 12.
the AC?
Wait, no, it
Because
can't be 12,
the
right?
radius of this big circle is 12, right? So this entire length from here to here is 12. But
It's
since
a
the
big
radius of this one is 3, that means the length from here to here, which is the same as the length from here to here, is 3. So
Oh, is it?
12 minus the 3 part is the 9.
Okay.
Is it 12 because 3, 4, 5?
Yes. All right.
Wait, 15? Right, 15, yeah.
Yeah, Aryan, I never draw anything to scale.
Oh, that would have been more useful. Because like 9 and 3 look the exact same one.
That's why she did it.
Nine. Okay, this is where the 9 comes from. So the entire length of AC, or in fact, let me do here. AC, which is the radius of the circle, is 12, and then BD, which is the radius of this circle, is 3. So if you sort of draw a line from B that intersects AC, like here, then this is 3, right? Because that's the radius of the circle. That means this also has to be 3 because this is the radius of the circle, sort of like it's just like transfer left over here. So then finding the difference, this top part would just be 9. Oh, it's not 12?
I said it wasn't 12.
Oh,
I'd be
Wait.
like, it can't be 12. Is it like, when you get 12, the moment would be like,
it is 12. I know that. All right, are there questions about this? And if not, we can move on to the Kahoot. All right, I'm gonna go to the Kahoot now. Wait a
Some
second.
people are just spamming in chat.
Yeah. All right. Oh, unfortunately, since I'm running the Kahoot, I can't really like join the Kahoot, you know? But here's the code in the chat. I'll share a screen in a moment.
yeah, no, Amy running the game.
Yeah, that means we won't, have pre-distance.
Someone
chat
screwed up the
rules.
chat for me. There's a big black line running through it.
It's not, for me, it's not black. It's just a crap ton of Chinese letters or something.
Yeah, that's essentially what it is for me. Okay, I'm gonna share screen. And
Oops. Sorry.
How do you even manage to do that?
I can't split my screen. It sucks.
Hagen, how'd you manage to screw it up that bad?
Oops. It was an accident, guys, I promise.
You know for a fact it wasn't an accident.
Oh wait, you guys can see the Kahoot, right?
Yeah.
Yeah.
obviously.
Okay, that's good.
You should just go call Taeyong and just tell her to code. Just make her guess and see if she can beat any of us. And Roy just tries to use my name.
All right, I'm gonna start now.
Someone's using my name.
Hey,
Am I that good that people have to use my name? I'm questioning that.
don't start.
You should be honored if people use your name.
Yeah.
Unless it's to mock you, which I'm 90%.
Well, I know it's
sure.
Ian,
Well,
so it's not like funny anymore.
I include a million
It's
alternate
obvious.
accounts.
It's me. It isn't me.
It's so tiny. It's obviously improper. It's not a perfectly drawn angle, as Amy didn't tell us.
Oh my gosh, Kahoot looks weird.
Exactly. It's like, I don't.
Yeah, this is an inscribed angle because all of its endpoints and vertex are on the circle. Okay, T on another celebrity. I guess you could consider this a celebrity too. And Aishwarya.
SpongeBob.
Yeah. What type of angle is Y?
It's an angle. It's an
I'm
angle.
dumb.
An angle,
Why
guys.
didn't you make?
Yeah.
It's a cyclic.
It's an angle. Why
Everybody
didn't you
knows
just
that.
write it? It's an angle. Couldn't you make angle and?
It's asking
That
for
would be the
type of
correct
angle.
answer.
Well,
That
this is
doesn't
its
mean
central
it's
angle
cyclic.
because its
an
vertex is at the
acute
center
No,
of
it
the
isn't.
circle,
It is not.
and
It
its
is a
endpoints are on the
cyclic
edge of the
angle.
circle.
It's
It
an
is a
acute
cyclic
angle, not
angle.
a central
It's so
angle.
bad at
No, it's
math.
actually
That is
technically
It's
not
a
acute
cyclic
angle because it's obtuse angle. And acute angle, since we don't know which
Okay,
type.
quadrilateral ABCD is what type of quadrilateral?
It's a circular. It's in a circle,
Duh,
so it has to be circular.
No, because it's a
cyclic,
circle, so
guys.
it's circular.
Yeah.
Oh shoot.
Oh, swear word.
Yay, congrats. Okay, here's the thing. This is a cyclic quadrilateral because all of its endpoints are on the circle itself, but this is also an inscribed quadrilateral because anything inscribed means it's sort of like on the circle. So all of its endpoints are on the circle, which makes it an inscribed quadrilateral too. So, yay. Okay. Winner AR is in
XX,
first
flag
place.
iron XX.
In cyclic quadrilaterals, opposite angles add up to blank degrees. Oh my
It's
gosh, I almost
obviously
said the
360.
answer.
It's obviously 360. A quadrilateral angle is add up.
Yeah.
No, it's cyclic, which
Just
means
add
it's a
them.
full
Just add
circle,
them.
so it's
So
fully rotational,
360.
which
90
means it's
plus 90
360.
plus
Yes,
90 plus
that's
90
so
is
obvious.
360. Guys.
Okay. It
Yeah,
looks
but-
like almost all of you guys managed to ignore what the people are saying in the meeting and choose the correct answer.
No,
So-
we're telling you guys the correct answers. Listen to us. Nothing could go wrong.
Wow. Oh my gosh, T and winner AR are like 1 point apart.
So
I'm
we
just sitting
winner
here.
AR,
It's like
we
the
winner
exact
AR.
same
They're
spot.
the
Find the
Mhm.
value of X. I hope you guys remember what the relationship is.
Those are obvious. It's 144. 72 times 2. Fun fact.
It's obviously 72, Ian. What are you, Aryan?
yeah,
What are you
72.
talking about?
I know, it's 72. Wait, what?
Okay.
I got it wrong. How would I get
So,
it wrong? It's 70.
The 72-degree angle is a central angle because its endpoint is at the center of the circle. Angle X is an inscribed angle because its endpoint is on the edge of the circle. And however, they share the same arc, which means that the inscribed angle is half the degree measure of the central angle. So angle X would be 36 degrees.
Ian, I'm gonna get you.
You are not going to get me.
Uh-oh, the
X,
chat got
wag
messed up
on
again.
X, X.
Find the value of
Ian's being
X.
killed.
You guys may fall for something.
I have absolutely no idea.
I keep putting
Well,
the
think
wrong-
about
this
it.
is pretty easy.
Pretend
Good job, Amy.
that you're dragging it around the circle. Like, think about it like that.
This is so
I'm just
disturbing.
putting the
right
wrong
now I'm
answers.
dumb. It's
Oh,
obviously
This one is
40, guys.
tricky.
Why is the
Yes,
circle
actually got
icon
it right.
in the front?
Okay, so for this one, it's a little bit tricky here. Let me get the annotate tool. Oops, what's happening? All right, so for this, right, because if you drag it around, it should say the same. So if you do this instead, you may get a better understanding that this is actually just an inscribed angle. And again, this is just a central angle here. So so angle X would be half the degree measure of the central angle here. So the degree measure of X would just be 20 degrees.
What do you mean it's 80?
No, it's not.
It is.
I don't even know what I'm doing at this point.
Wow, lots of movement.
Let's move.
Okay, find the value of X again.
Who is X anyway?
Who is X? That is the X is the X in the middle of the trapezoid.
Who's
That's
X,
the
and why are
angle
we
measure she's
finding it?
asking. It's 360 degrees, so it's green.
Okay, so
But you
almost all you
came out
guys got it
half a
right.
second away from pressing it, but it didn't lag.
Oh, .com is sponsoring you.
I need
So,
the most fair.
The 75 degree angle is for this arc here, and it's also an inscribed angle. The angle X is also an inscribed angle, and it's of the same arc over here. So X is also 75 degrees. Okay.
X, X, what?
Whoops, where's the next button?
Let's get rid of Ian. Is the
Okay.
game over?
Oh, someone's named Ian is bad.
Find the value of the missing angle. Uh-oh.
I just guessed.
Why does the angle go missing? Why don't?
It looks like one of the... I don't know if the answer's actually on here.
Oh no!
Just choose the answer which is closest, because there's one answer that's very close to the real answer. So just choose whichever one is
Too bad
closest.
because I
For some
always
reason-
play.
That a second earlier.
Yeah. It looks like an optical illusion to me for some reason. That's why I keep getting it wrong for some reason. I mean,
Okay, yeah. So the actual answer is 101 degrees, not 100 degrees. And I'll explain why. So this picture, you see you have this 68 there's actually a couple ways you could go around solving this. So first, we can solve it by noticing that like this arc, right, is in this angle. So this 68 degree angle shares this arc with this angle down here. So this is 68 degrees. The 33 degree, how do I change colors? Oh, I can't. Okay, so this 33 degree angle has this arc up here, and it shares it with this angle here. So this is 33 degrees too. So this entire angle would be 101 degrees. This other way you could solve it is by noticing, hey, there's a triangle here. And so this angle over here would be 180 degrees minus 68 degrees minus 33 degrees. And let me use my calculator because I'm too lazy to do math. That's 79 degrees over here, right? But then you can also notice that this over here, 79, that, hey, there's this big quadrilateral here, which means that this angle must be supplementary to this one. So this is 180 minus 79 degrees. So 180 minus 79 is 101 degrees.
You're gonna have to skip most of them. We have like 7 questions left and you're gonna get lost.
That's true.
So we're gonna have to
Just
get ready
click
for
randomly,
spam.
guys.
Multi-select. Which of the following angles is congruent to ABE? And there's 2 answers, by the way.
Your viewing image thing, I can't see the problem because of it.
Oh, sorry.
Oh, thank you.
There.
At this point, I guessed.
Well, you know there's 2 right answers, so.
I knew one of them, but I just like.
Okay, so here are the angles. So this angle, right? So it's ABE or it's ABD, which is the type of.
ABE. I kept doing it for AEB.
And then over here we have ACD. So those are the angles. Okay. Multi-select. Which of the following angles is congruent to angle
There's a drawing
ADB?
in the middle of the screen. Okay.
Oops, sorry.
Oop.
Okay, find the area of quadrilateral.
I'm tempted to.
Guys, randomly guess.
Find the measure of angle BAC.
I randomly guessed that I spammed somehow. And I get the correct answer. I don't know how I did it, but.
Oops.
I kept
Okay,
1,000 somehow.
BAC. So this is actually an isosceles triangle. Why? Because this is a radius and this is a radius, so that means these 2 sides are the same, which means that these 2 angles must be the same. Yay. So this is 50 degrees.
I just use scale and well, there's only one angle that's close to 90 degrees.
I mean, you could do that too.
That's what I did.
These 2 are 50-degree angles, so this one must be 80 degrees.
I got a perfect 1,000 somehow.
Okay, line segment BD is the diameter of a triangle. DCB has area 8 square root of 3. Oh, I should have made you guys do that. That one was actually a good question. Now I'm sad. Okay. If each of these 3 circles has a radius of 2, find the area of the shaded triangle.
Oh no.
I hope I got it right. I'm not sure. I know how you do it, but I kind of forgot how you do it.
I didn't even get to put an answer. I was just too busy spelling.
Bro, why would you name yourself me? How could you?
Okay, so
Rude.
the radius is 2, right? So this is a radius of a circle, right? It's the radius of this circle here. So that means that this is 2. And that means this is 2, which means that this is an equilateral triangle with a side length of 4. And if you paid attention in our classes, you would know the formula, which is the side length squared times the square root of 3 divided by 4. So the side length is 4, so it'd be 16. Well, you can't see that. 16 square root of 3 divided by 4. So that would just be 4 square root of 3. Okay.
Duh, baby.
What's the degree measure of arc AB?
Which arc are we talking about? I'm confused.
Minor arc.
Oh, good, yeah.
if it's just
You
two
might have said
letters,
that second
if-
too late.
no, here's the thing. If it's just two letters, it always refers to the minor arc. But if it has three letters, then it always refers to the major arc. So, yeah. Now, I'm going to show why. So, remember that this doesn't actually tell you the degree measure of the arc. This is just an angle measure. But this angle here is the degree measure of the arc. So, let's just call this x. But hey, this x is a central angle of this arc, and this angle is an inscribed angle of this arc. So x is twice the length of this, or sorry, twice the degree measure of this. So x equals 116. Okay. All right, let's look at the podium. All right, in third place we have Sharvie. In second place we have Ian is bad. Who's Ian? Yes, if you need to go, you can go.
I agree with whoever the second place is.
Okay, and down here we have winner AR and SpongeBob. Who is Ian is bad?
No, it's me. It's me.
Who's talking?
I'm in the name. It's
Charles
me.
is
It's not
Charles.
Charles.
Ian is bad as Charles.
No,
Ian
it's
is-
Spread the
me.
message, boys.
It's me.
All right, Ian is bad is
I'm
gonna
in the
be
name.
Charles.
It's me. It's me.
Okay, also I gotta go. Bye.
All right, bye. And
Alright.
T is myself, so yay.
Wait, so would you count fourth place
You're
then?
lying to us this entire time.
What?
Like,
So
So
you're gonna
yeah,
count fourth
Advika,
place?
you would be third, Sharvie would be second, and Charles would be first. Because
Okay,
T is me.
Bro,
just T.
cheating?
You guys still
Damn,
have to beat me
damn.
someday.
Okay, I'm rickrolling everybody.
Wait, but that's not possible because you created the Kahoot, right?
She's on her phone.
No, it's possible. It's possible. I did that with my parents.
I did it on my phone.
Wait, did you create the Kahoot?
Yeah.
You
I made
already
the-
know the answer.
No, I didn't. I almost got the wrong answer. I didn't check the answers. I was solving them on the spot.
Almost.
All right. So
12,000 points from 12 questions. You definitely want to check it.